All right, yeah, so thank you for joining the session. What we're going to talk about today is using dynamic notes. So without further ado, let me share my screen. And if you could go to student.desmos.com and type in this code, and it's going to restrict you to just do the first screen. So do this as a math teacher, do it thinking as if you're one of your students, however you want to, just kind of paying attention to the different things that are happening on the screen. All right, so there are a lot of things that are happening on the screen, but the first thing that I want to pay attention to is, so like, I'm glad that one of you put in a wrong answer and one of you put in the right answer. So this is a note that's not using any sort of dynamic feedback, but this one is. And so just so you can kind of see the difference between someone that got it right and someone that got it wrong. All right, so just thinking about why you might want to use the dynamic note versus not a dynamic note, what are some reasons that you might want to use that instead?
I mean, they seem kind of the same to me, but the dynamic note's a little bit more clear. It's not quite so wordy, it just cuts straight to the point.
Yeah, and that was just a product of me putting different things in there. So I could have, in this one, I could have made it look almost the exact same way, but the thing that would have been different is I would have lost, like up here, I didn't have the ability to bold anything, and I didn't have the ability to change any color. So that's kind of like the main part of what we're going to look at is reasons why we might want to use a dynamic note. And when we go to another graphical representation, you'll see more of a reason why it would be cool to use the dynamic note instead of not a dynamic note. So there are different things that I had to do to make this work. So what I'm going to do now is kind of show you the background of everything. So on this, I had the information here, which was evaluating the expression, and then here where you're going to put in the answer. And then I gave you two different things to look at. One of looking at feedback without a dynamic note. And so this is something that in past sessions, the way I've shown like how to put information in a note is there's nothing that's actually here. Everything is inside the computation layer. Whereas what I'm going to show you with the dynamic feedback, there is actually some stuff that's here, but then also some stuff that's in the computation layer. So first I'm going to show you this other one where there's nothing here. Everything's coming from the computation layer. And one thing to pay attention to is the note is going to reference the student answer. So where they put their answer, that's the label that I gave this input, just so those two components can talk to each other. So for example, when I go into this component and I go into the computation layer, I have a few different things here. So one thing that I wanted to have happen is this first line that says hidden, and I called this boring feedback because there's nothing where I changed any colors, there's nothing that I made bold. And so this line right here, so it's hidden when that feedback button has been pressed 0 times. So what that means is I haven't pressed this button, so that note hasn't appeared. But once I press it, that's what's making the note appear. And then what's happening in the note is I have a different message that's being given to a student. So that's where I have this line that says content. And now I'm saying all of the content that I want to have in the note. So this first line says that when student answer, and that was where you were submitting the answer to the problem, when student answer dot numeric value, so the number that you actually put in for the answer when it's 6, the message that I'm going to tell you is great job, you evaluated this correctly. And just like a quick side note of how I got this emoji to pop up, I just right click and hit emoji and you just have a bank of different things you can choose from. And then when not student answer dot numeric value equals 6, so they're putting in an answer, but it's not equal to 6, then you got it wrong. And my message to you is your answer was. And so this is where I had to define the answer. So this is the piece that gets a little bit tricky if you're not using a dynamic note is I want Desmos to read what the student input as an answer. So up here, I made that variable where I'm saying that the word answer is the student answer dot numeric value. So whatever the student puts in that math input, Desmos is going to read that they entered that in. So your answer was whatever they actually submitted, but the correct answer is 6. And that's the message that I'm giving to them. Otherwise, in any other situation, I'm not going to give you any feedback. So again, I type in something that's not right. My feedback without a dynamic note is just point blank, this is what you said, this is what the correct answer is. All right, but with the dynamic note, I'm doing some more stuff. So now I have the ability to bold something, change the color. So there's different things that can stand out to a student so that they can like really see this is one piece of it, this is the other piece of it. So the way that I did that is now I have dynamic feedback, and so that's another button. So again, I have that hidden line of the dynamic, it's hidden when dynamic feedback dot press count equals 0. So when that button has been pressed 0 times, I'm not going to see this message. So it's pressed 0 times, nothing is there. I press it, now I see the message. And so what I did here, instead of having to give all of this different content, all I had to do was define a variable. So I said that the variable answer is student answer dot numeric value. So what this means is where you type something into that component, that's what that variable is. And then I'm saying that the correct answer is 6. And so the reason I did this is because now when I come in here, kind of like how I did this, I'll do this from the beginning, is I just typed your answer. And this is where Desmos allows me to bold it. To be able to pull in one of the variables from the computation layer, I go here and it gives me something to choose from. So I defined their answer. And sometimes this happens. It can't be bold when you're trying to bring in a variable, but now I can bring it in. And so also when you want to do something in color, this is actually something that I learned the other day from someone off of Twitter. I didn't even know that this was a thing, but you can't pull in color from Desmos, but what you can do is you can open up a Word document and you can say, all right, I want this to be blue. So I'm going to turn it blue, and then I'm going to copy it, and I'm going to paste it in here, and it actually pastes in as that different color. So that's what allows me to bring it in as a different color. And then I'm going to pull in the variable that I said as to what was correct. And now if I wanted to, I also could click on each of these variables, and I could italicize it if I wanted to. It's really up to you just how you want to make information stand out to a student. So now when I preview it, I say 4 is my answer, and now I see my feedback with a dynamic note where I can kind of get in that different font style. All right, so I feel like I did that really super fast. Are there questions about some of the stuff that I just showed? You want me to go back and show you again? You want me to re-explain something to you? Or are we all good? All right, I guess we're good then. All right, so I'm gonna go to the next one. So now this is actually gonna bring in like the real math piece. So what I'm gonna do is I'm going to restrict you to screen 2. So if you could go to screen 2, and I want you to kind of play through that, and I want you to watch what happens as you start to do what's on the screen. All right, so on this one, I also want to point out a couple of things that I did with the coding also, so that you would recognize that I have put some coding in here to mark things as correct. So I know that Diego has correctly plotted a point on the graph, but I know that Hio and Moon Duchin, sorry if I mispronounced that. I know that you're working, but you haven't quite gotten to the right answer. But what I'm going to do now is I'm going to pause you guys so I can show you the background of what's happening on this. All right, so I gave information about a word problem, and I have set in stone these lines. So I don't want students right now to worry about graphing lines. I want them to figure out, all right, if I move this point around, this means something. And I want them to understand what's happening and what this point of intersection means. And so what's happening with this note is, again, I've done a lot of the bolding like I did on the last one so that I don't have to put everything within the content of the note. I can put all of the information, and the only thing that I have to go and put into the CL are the coordinates of the X value and the Y value of the coordinate point. All right, so if I show you what the graph looks like, in here I have the two equations, and then I have the draggable point. So I have the draggable point AB, and that's this point right here. And so what happened with this one is, I'm going to go ahead and take this out just so you can see what I did, is I just put in the point AB and I hit enter so that these would appear as sliders. I also changed the color so that it would stand out from those lines that we have graphed. And so this is really the only thing that's happening, is you have to put a slider for a point for the students to be able to drag it. And then what I did is, you know, working in this one, I know that it's going to be integer points. So I went in and put my step as 1 for the X value and the Y value. That way students can more easily maneuver that point around the screen. And so the only thing that I really have to do in terms of doing this dynamic note is I have to make these two components speak to each other. So what I ended up doing is right here, the solution of the ordered pair, and then what it means, that's all coming from this draggable point. So that means I need this draggable point, I need the X value and the Y value to talk to this note. And so the way I did that is in the CL, I have two things. I know that pizza represented what was happening on my x-axis and wings was what was happening on my y-axis. So that's why I use the variable pizza and wings. But so pizza is coming from graph 2, and it's the number A because A is what I called the x value. And then wings is equal to graph 2, the number that I put as B because that was the y value. So then when I came in here, just to kind of show you how I pulled all of that in, I know that the solution is whatever the x comma y is from this graph. And so that's where I pull in the variable pizza, and the y value was wings. And so what that means is the price of one pizza was whatever my x coordinate was, and the price of one basket of wings is whatever the y coordinate was, which I called wings. So now every time I move this point around, this is changing to represent where I am on the graph. So students can start making that conception of this is what that is. If you also notice, when I'm moving this point around, every time I'm not correct, there's an X there, but the moment I'm right, there's a check. And so, I'm sorry, did you have a question? Nope. Okay. So to do the correctness checker, what I needed to make happen is what was correct was when this dot number A was 7. So when my X value was 7 and this dot number B, so my Y value was 5, that's when it would show up as correct on the dashboard. So again, X everywhere, but the moment it was right because my A value was 7 and my Y value was 5, it pops up as a check mark. All right, so questions on that? You can come off mute, you can put it in the chat, whatever you're most comfortable with. All right, in that case, what we're going to do now is I'm going to share this activity with you. But before I do that, because what's going to happen on the next screen is you're now going to try something. I'm going to have you try making a draggable point and having the graph component talk to the note. So your goal is going to be making a vertex a draggable point, and then make the note say what the student's vertex is using bold and or italics and or a colored font, whatever it is, it's going to make information stand out for you. So when you open up this activity and you go to slide 3, I've put 2 things there for you already. I've put a graph component there for you, and I've already titled it graph 4. And then inside the graph, I've started doing the information in here, which is just the quadratic formula in vertex form. And then I've given you a blank note. All right, so I'm going to go back into the chat. And in here, I'm going to go ahead and give you this activity. So what I want for you to do is open up this activity and copy and edit it and go to slide 3. And on slide 3, I'm going to keep the directions up here. So this is kind of a you try and ask questions as you go and see if you can make this happen. All right. All right, so how there's, yeah, that little symbol in there. Let's go in there and let me see what that is. So if you hover, can you hover over the exclamation point? All right, so, okay, hit done for a second. I think I know what it is. So everything that you did is in this graph. In the graph is graph 4, but in your CL, you still have it as graph 2.
Oh, okay.
So you need to change that to graph 4. And then it should work.
Okay, yeah, looks good now.
All right, so now on this one, and just an additional thing that you can do. So X out of this, and can you go into the graph? All right, so now you have a couple of options too. You can totally keep it the way you did. So you went ahead and you said y equals x plus 5 squared plus 3. Now, and this just is in terms of what your intention with students is. Is your intention to have them take that point and put it on top of the vertex, in which case, you know, that works if that's what you're looking for. But if it was something where you want that parabola, if you want it to move with the draggable point, where you have x plus 5 squared and 3, keep it as x minus h and then plus k. And then when they move the point, they're going to move the entire parabola. So at the end of the day, it's really just your intention of, do you want to move the whole parabola, or do you want to move the vertex to where it is? So that's all, you know, teacher decision.
Okay.
All right, cool. All right, well, since you have that one figured out, then what I do want to do is I'm going to, take over, and I'm going to show what's on the next one. All right, now, Chris has come to a couple of these before. Andrew, this is your first time, so there's going to be a lot of information on this one, but I am going to go through it piece by piece. If you get to a point and you're like, wait, slow down, please tell me to slow down. All right, there's a lot of things that I have going on this one. And again, when I was thinking about making this, I had to think about, okay, like, what is it that I want students to do? What is it that I want to make sure they do things right, or is it okay if they do things wrong? So just like thinking about all of the different possibilities. So what I've done is I've given them 2 linear equations to graph, and I chose this because I think in algebra most people are getting 2 systems of equations at this point. So what I've done is I've given 2 equations, and what's going to happen is first I've given these points to graph f of x and to graph g of x. So what would end up happening is they would graph f of x. So once they start moving these points around, that's when the lines start to show up. And I'm going to show you how to do that. And then from here, I'm going to create a slope of -1/2. And then my g of x graph, I have a y-intercept of 6. And then my slope is up 1/3. And then they're going to lock their lines. And watch what happens to these draggable points when I click the button. What happened?
They became points.
They're not draggable.
Right, they're not draggable anymore. So they've locked their lines in because now from here, I've made this new draggable point appear. So now this says now drag point D. So it lies on the intersection of the two lines. So this is where I've brought in that dynamic note also, is this is going to start tracking what they're calling the solution. So every time they move the point, it's following along. And then also, if you look up here at the dashboard preview, it's wrong, it's wrong, it's wrong until I go to the right spot. Once it's on the right spot, the teacher is going to know it's correct, but the student might not. You always could put a piece in here of once they get to the correct spot, you could tell them that they're correct, or you could just kind of leave it up to, you know, using written feedback and letting students know that they're correct. But then, so from here, they're right. All right, so it doesn't seem like a lot happened, but a lot just happened. So the first thing was I had to give some points so that students could create some lines. The only disadvantage to how I created this problem, and again, it was just the way I intended to do it, is if they lock their lines and it's the wrong answer, I'm keeping their wrong answer, because then as the teacher, you know, a kid's going to go in here and I'm going to see that they got this wrong on the dashboard. And so when I see an X pop up, I'm going to be like, all right, well, I need to go figure out what they did wrong. And as the teacher, I might go in and see, okay, you understand how to find the point of intersection or the solution, but you don't know how to graph lines. So at least I know what your issue is. But, you know, if they end up putting point D here and saying that that's their final answer, I know we have a lot of problems going on. All right, so how I made this work is in my graph. And so this is also something that if you start to look in some of the activities that I made in my graph, you might see some folders. And that's just how I go in and just like keep all of the information separate. So I had three things that were happening. I had the information to graph f of x, the information to graph g of x, and then the information for that point D to pop up. All right, so for f of x, everything that's in here is a slider. All right, so what I had is I'm going to get rid of this just for a few minutes. I'm going to bring it back because I'm actually going to just delete these because I think it'll be easier to follow along if I kind of show you the steps to do it. So what I had to do is I have these 2 points right here. So these came from the point AB and the point CD. That was to graph f of x. So I just took one of those points and I labeled it as f of x so that it would always follow along with that line. That way students could identify where f of x was and where g of x was. All right, so right now, if I was to look at this, they're going to move these points around, but I haven't done anything to lock them because I took all of that away. So I have my 2 points that I've plotted, and then in order to make the line show up in between those 2 points, I had to use point slope form to make that line pop up. So this is just point slope form between these 2 points. That way, no matter where these 2 points go, the line is always going to connect them. And then I just put them on top of each other. So when you look at it on a graph, you don't have but like so much happening at one time. All right, so that's kind of the first step in there is I had to make the sliders for the points. All right, now what I had to have happen is I knew that I was going to use this button to lock the lines. All right, so I'm going to put a variable in here, but I did that on each ordered pair. So like right now, these 2 ordered pairs are draggable, but I don't always want them to be draggable. I want them to be draggable when I have not pressed the button. Then the moment I press the button, I want them to not be draggable anymore. So the first thing that I had to do was I copied each one of these points so that it appeared twice, because there's going to be a time when you can drag it, and then there's going to be a time that you can no longer drag it. Same with this one. There's a time that you can drag it, and there's a time that you can no longer drag it. Now I'm going to set a variable to it. All right, and honestly, there's no reason that I've chosen this variable except that this is how I learned it, so I'm just teaching it the way that I learned it. You can use any letter that you want. So I'm going to say when p equals 0, and I'm going to eventually show you why I'm doing that. And then it's not going to be draggable when p equals 1. And then same thing for this point. It's draggable when p equals 0. And then it is not draggable when p equals 1. Right, so this is where I'm going to bring in the computation layer. I also, just side note, I did put some bounds in here. As again, I always do that to make the graph look the way I want it to look. So the number p, and that again, so p equals 0, it was going to be a draggable point. And when p equaled 1, it was not going to be a draggable point. And all of that was being played on that lock button. So when lock.pressCount is greater than 0, my condition is 1, otherwise 0. So what this is saying is the lock has been pressed more than one time. I want p equal to 1, otherwise p is going to equal 0. So right now p equals 0 because I have not pressed this. I can move it around, I can move it around, press the button. Now I can't move it anymore. All right, do you have questions about that piece of it at all? Because then I did the exact same thing with g of x. I went through the same process of I had to duplicate the point, and then I had to do p equals 0 when it was draggable and p equals 1 when it was not draggable. All right, then the next thing that I had to do is that was f of x. And again, g of x, exact same thing. I just had another line in there. So again, I had to use point slope form to connect the 2 points that I had in there. And then I had the solution because if you notice right now, I don't have that extra point D. So that point D doesn't show up until I start graphing stuff. So once I press this button, that's when I had point D pop up. So then here, my solution, and I'm calling point D x1, y1. And so this only is going to appear when the button has been pressed. But in this case, it was draggable here because when the button is pressed, that's when I want this draggable point to show up. And then in my note, I said, now drag point D so it lies on the intersection of the 2 lines. Your solution is, and then here's where I defined that x was my graph 3 number x1 and y was my graph 3 number y1. And then again, the extra piece that I did on the coding to make sure a check mark appeared in the dashboard is I said it was correct when this number x1 equals -6 and this number y1 equals 4, because I knew that -6, 4 was the ordered pair that was the solution to these two, to this system of linear equations. All right, so I feel like I just did a lot and you may have followed the whole thing. Are there any questions on how I did any of that? All right, cool. Well, so that was all I had for you for the dynamic note. And of course, like I said before, I did a lot more in there than just the piece of connecting a graph to a note, but it just kind of gets your feet wet of how you can give feedback to students, but make it connect to all of the thinking that they're doing.